what happens when a substance changes state. So here we have a heating curve of a particular substance. At the start, when the temperature first starts to increase, this is the solid heating up. And as we know in a solid, the particles are regularly arranged in a repeating pattern, fixed positions, and their movement is limited to vibrations only. At this point here, forces of attraction between the particles are weakened and overcome. The temperature remains constant because the energy that you are still giving the particles is being used to break those attractions. So when the graph is flat, we're having a change in state taking place. So here we have melting taking place. And if we read off, that would be the substance's melting point. Once all those attractions, or many of the attractions, have been overcome, we then turn into the liquid phase. Now, in the liquid phase, we need to remember that most of the particles are still touching. Every particle should be touching at least one other. But we can see that arrangement is now random. There is no regular pattern like in the solid. Now the movement of particles is no longer limited to just vibrations, but they can move positions. The temperature is increasing as I'm increasing the temperature of the liquid. At this point here, the force between these particles weakens even more, and the particles start to move apart from each other. Again, change in state, so this is now boiling. And in the boiling process, the forces between the particles are completely broken, and nothing is no longer holding them together. So this is the substance's boiling point. Once we've turned the substance into a gas, and all the forces holding those particles together have been broken, the gas temperature will start to increase. And remember, with our particles in the gas, particles are random, they're far apart, and they're moving at high speed.